All right, good morning, geometry. Today we're going to be going through our 4.2 notes. Before class starts, make sure you have turned in your city project. If you did it online, just submit it on Schoology. If you did it on paper, you can turn it into the bin with your rubric. For homework for 4.1, I'll just check it off tomorrow when I'm back, so don't worry about that. But we're going to start with our warm-up. So we're going to do a little bit of practicing with our exponent rules again. So go ahead and pause and try those 3 problems. Okay, so now that we're back, let's go ahead and double check our answers. So with division, we are subtracting our exponents. So our final answer for A should be -1/2. And then either n to the third out front, or you could leave it as n to the third just on the top. Either one is fine, they're the same. Question B, your final answer should be 1/4 x to the 7th, and then same as question A, or you could put your x to the 7th on top with the 4 in the denominator. Either one is fine. Question C, write the equation of the line parallel to our given line through the given point. So first thing I'm going to do is solve for y so we can figure out our slope. 3y equals -5x plus 21. When we divide by -3, divide everything by -3. So our equation is y equals 5/3 x minus 7. The only thing that's important to us is the slope. Since the slope is 5/3, the parallel slope for the new line is going to be the same, also 5/3. And then I didn't tell you what format to put this in, so you're welcome to have stopped at point slope form, but I'll do both. So one of our equations, if we plug it in, we have our point, x1, y1, and I have our new slope, which is the same. Y minus y1 equals our slope times x minus x1. So you might have stopped right here because I did not specify. If you did turn it into slope-intercept form, your final answer would have been y equals 5/3 x minus 1/3 if you did it that way. Okay? So today's lesson is going over slopes of perpendicular lines. So we're going to do a lot of the similar stuff that we did last week, but the slope is going to be a little bit different. So for slopes of perpendicular lines, they have opposite reciprocal slopes. So opposite is meaning the signs are different. So if one's positive, one's going to be negative. And then reciprocal is meaning the inverse of a number. So we're going to flip our fraction. So we're going to start off just by looking at a given slope, and we're going to find what the opposite reciprocal is. So for question A, 3/4, so it's positive. So I'm going to change the sign to negative, and then I'm going to flip the fraction. And then for B, 2 is positive, so I'm going to make it negative. But any whole number is really over 1. So when we reciprocate it, it's going to be -1/2. So go ahead and pause and try C and D, and then let's check our answers. All right, checking our answers. So C is negative, so our opposite is going to be positive. And we're going to have a positive 8/7. And then for D, 1 is really over 1, so it's not really going to change our answer. We're going to mainly just change the sign here. All right, let's go ahead and give this a go. So properties of perpendicular lines. This is when they are going to intersect to create that right angle. So 90-degree angle, it's going to be perpendicular. And how we know that is by looking at the slopes of the lines, and they're going to be opposite and reciprocal. So opposite and reciprocal slopes in order for it to be perpendicular. Also, just a reminder, this symbol, kind of our upside down T, means perpendicular to. So if you see that symbol, that's what I'm implying. So your book also gives you a different way to kind of think about your slope if you want to check that you did this right, is you could look at the slope criteria. So that's just saying if we take the product, so multiplying those two slopes, the product has to equal -1. So for example, I'll use the slopes from the picture above. So if I take one of the slopes was 2, the other slope was negative 1/2, and I multiply those, I end up with a product of negative 1. That's confirming that our two lines are parallel. So, or sorry, perpendicular, not parallel. Just another way to kind of think about it. All right, let's go on to task 1. Task 1, I'm going to walk through A with you, but then I want you to try B and C. Formula that'll be helpful for us here is our slope formula. Slope is our change in y over our change in x. Remember before, our strategy here is to help us label our coordinates if that helps. So for the slope of line AB, x1, y1, x2, y2. So I'm going to do the change in y, so 4 minus 3, negative 1 minus 2. So we get 1 over a negative 3. And then I'm going to do the same thing for line CD. Again, label your coordinates so we plug everything in the right spot. Change in y, 6 minus 3, over change in x, so negative 4 minus a negative 5, so that double negative is going to turn into our positive. We end up with 3 over 1, which reduces down to 3. So I'm kind of looking at our slopes. So check, they're opposite signs. One's positive, one's negative. And they are reciprocals. So this tells us that, yes, they are perpendicular. So AB, line AB, is perpendicular to line CD. And that's because the slopes are opposite and reciprocal. So go ahead and pause and try questions B and C, and then we'll check our answers. All right, let's go over question B first. So label your coordinates, x2, y2, then we're going to plug that into our slope. So negative 15 minus 13, double negative turns into a positive. I got negative 28 over 7, which reduces down to a negative 4. And then for CD, x1, y1, x2, y2, negative 7 minus 5 over 1 minus a negative, so plus 2. We end up with negative 12 over 3, which reduces down to negative 4. So hopefully this looks a little familiar from last week. They are the same slope, which means these are actually parallel lines, but they are not perpendicular, which is what we were looking to find. So AB is not perpendicular to line CD. They're actually parallel because they have the same slopes. All right, let's go check and see. Question C. Label your points, x1, y1, x2, y2. Let's find slope of line AB. We get 2 minus 8, 3 minus a negative 3, so plus 3. We get negative 6 over 6, which is a negative 1 slope. All right, CD, so x1, y1, x2, y2. We're going to plug them in, negative 1 minus 1 over 5 minus 7. Negative 2 over negative 2 turns into a positive 1. So this is kind of like one of our examples from a previous question. These are going to be perpendicular. Perpendicular because the signs are opposite and they are reciprocal. One is reciprocal of itself. So AB is perpendicular to line CD. And that's because our slopes are opposite reciprocals again. All right, finding slope. We're going to go on to task 2, where we're going to step it up a little bit. We're going to give you some equations, and we're going to determine if the lines are perpendicular. So remember, our two formats are y equals mx plus b, or our y minus y1 equals m times x minus x1. Okay. All right. I want you to try question A, question C, and then you can pick either B or D. So you're going to do 3 questions off this page. Identify the slope given our equation, and then I want you to tell me if they are perpendicular. So go ahead and pause. You're going to do A and C, and then your choice on B and D. All right, coming back. Let's check our answers. So for question A, I'm going to look at my slope. So slope for our first line is -3/2. Our slope for the second line is +2/3. Yes, those are going to be perpendicular. We have opposite signs, so one's positive and one's negative. And then the the reciprocal as well. So 3/2 and then 2/3. All right, second question I asked you to do was question C. Both of these equations are not in our format where we can pluck out our slope. So first thing we're going to do is convert it to slope-intercept form. So solving for y, don't forget to divide everything by that -6. So we have y equals 2/3 x minus 2. So that tells me our slope is 2/3. And then we still have to actually solve for the other equation as well because it's also in the wrong format. I'm going to subtract our 3x. We get 2y equals -3x plus 10, and then we'll divide everything by 2. -3/2x plus 5. So slope here is a -3/2. All right. Yes, they are perpendicular. They have the opposite signs, so one's positive, one's negative, and reciprocal slopes. It needs to have both of those things or it's not going to be perpendicular. All right, depending on what question you chose to do. Question B, I'm going to solve both of these for y. Divide by 2. -1/2 x plus 1, so our slope is -1/2. And then solving for y for the second equation, divide everything by -3. We have y equals 2x minus 7. So my slope here is a +2. So if you did question B, yes, they are perpendicular. Our slopes are opposite signs, positive and a negative, and they are reciprocals. Because remember, any whole number is over 1. All right, if you chose question D, second equation was already in slope-intercept form, so we know our slope was 1/3. First equation, we did have to solve for y. We have -3x plus 2. We're going to divide everything by -1. So we end up with 3x minus 2. So our slope is a +3. So for question D, they are reciprocals, but they are not opposite signs. So these are not perpendicular. We would need both of those things to be true. All right, moving on. So similar to how we ended it last week with parallel equations, we are going to talk about writing equations of perpendicular lines. So again, we have those two formats, slope-intercept, y equals mx plus b, and point-slope form. Remember, point-slope form is our good one to start with, and we can always solve for y depending on what the question asks for. So I'm going to go through 2 examples for you, and then I'll give you some to try. All right, so example 1. First thing is to look at the slope of our given line. Our given slope, oops, sorry, not 3, it is 2. But we want this to be perpendicular. So I'm actually going to make a perpendicular slope. So our perpendicular slope, since that's positive, it's going to be negative, and then I'm going to reciprocate it. So instead of 2/1, it's going to be 1/2. So from here, we're kind of done with that original line, and we don't need that slope anymore. We're going to focus on the point and the slope that they gave us. So this is where if you plug this into your y minus y1 times x minus x1, our point slope form, I'm going to plug in y1, which is 0, our slope that our perpendicular slope, and then x minus 4. I'm going to simplify that 0 on our left side so we get y equals negative 1/2 x minus 4. So I didn't specify in the directions, but if I did, this would be your point slope format. And then we're going to practice both, so I'm going to also convert this to slope intercept. I would distribute the negative 1/2, and we'd end up with a positive 2. So solving for y gets you your slope intercept form. So big difference from last week when we did parallel is the slope. Similar process, but the slope is going to be different. All right, I'm going to walk through one more. So example 2. This is an example where I don't have our slope intercept format, so I'm going to solve for y. So I'm going to move my 2x over. 5y equals negative 2x plus 5, and then we're going to divide everything by 5. Negative 2/5 x plus 1. So out of here we need our slope. The slope is negative 2/5. But I would like the perpendicular slope. So perpendicular slope is negative 2/5. Now we're kind of done with that original equation and our original slope. And we're going to use our point and that new slope, the perpendicular slope, to write our equation. Y minus y1 equals m times x minus x1. I'm going to plug everything in. Y minus 7 equals our perpendicular slope, so negative 2. Oh, I didn't actually do the perpendicular slope, you guys. Originally it was negative 2/5, so we actually make this a positive 5/2. All right, I got parallel on my mind. Perpendicular, change the sign, flip your fraction. So 5/2, there we go, easy fix. And then x minus 6. All right, if I said leave this on a point slope form, you'd stop right here. But I'm going to have us practice both ways today. So you're going to go ahead and solve for y. So we're going to distribute our slope. So we get 5/2x. And then 5 times 6 gets us 30, divided by 2, so negative 15. And we're going to add our 7 to both sides. So y equals 5/2x minus 8. And that would be our equation if we said slope intercept form. All right. So 2 examples. I want you to try this out on our task 3. So task 3, I want you to try, let's see, it's questions. We'll do a couple. Let's try A. And then I want you to try B. And if you have time, go ahead and try C and D, or we can kind of use those tomorrow as a little quick review when we're back together. So go ahead and pause and try those 2 for sure. All right, let's go over A first. So question A, step 1, I'm going to look for my slope of the line they're giving me. So our slope is negative 4. But I need the perpendicular slope. So instead of a positive 4, it's going to be a negative 4 is going to be a positive, and then it's going to be 1/4 because 4 is over 1. So we're kind of done with all of that, and we're going to use our point that they gave us, x1, y1. And we're going to practice in both formats, even though I didn't specify in the directions. We're going to practice both like we did last week. So y minus y1, which is 1, equals our perpendicular slope, 1/4, times x minus also 1. And we would stop right here for that first equation in our point slope form. Solving for y gets us our slope intercept. Y minus 1 equals, distribute your 1/4, minus 1/4. Then we're going to add 1 to both sides. So your slope-intercept should be y equals 1/4 x plus 3/4. Intercept form. Okay. All right, check that one. And then let's go to question B. Question B, we're going to write the equation of the line perpendicular. So our equation here is not in slope-intercept form, so we're going to solve for y to figure out what our original slope is. We'll divide everything by 3, so our equation is y equals negative 2/3 x plus 2. So our original slope is negative 2/3, but we need the perpendicular slope. So instead of negative, it's going to be a positive 3/2. Now we're kind of done with this original equation and that original slope. We're going to use our perpendicular slope and the point to write our equation. Y minus a negative 6 equals our slope, our perpendicular slope, so 3/2 times x minus a negative 2. So double negatives, make sure we turn those into positive, so we should have y plus 6 equals 3/2 times x plus 2. And this would be our point slope form. Solving for y gets our slope-intercept form, so we're going to distribute our slope. Y plus 6 equals 3/2 x plus 3. Subtract your 6 on both sides, we end up with y equals 3/2 x minus 3 for slope-intercept. Okay. So go ahead and double check A and B. And then C and D, let's save those for tomorrow when I'm back and we can kind of use those as a little extra practice. And then let's go to task 4. So task 4 is touching on our perpendicular lines for vertical and horizontal. So if you remember when we talked about it before, I'm going to just draw us a little quick graph. It's not very good. There we go. So if I have an equation, 1, 2, 3, 4. So y equals 4. And we talked about parallel lines being also horizontal. But if I wanted to make a perpendicular line through this point, 3, 1, I'm going to focus in on the x coordinate this time because we're going opposite. Instead of horizontal, we're doing vertical. So x equals 3. So vertical and horizontal lines are going to be perpendicular to each other. So if we look at example A here, so in task 4, question A, the equation of the line perpendicular to y equals 3. Y equals 3 is going to be a horizontal line. So that's focusing on the y coordinate. And if I want to make something perpendicular to this, I'm not going to do another y equals. I would focus in on the x coordinate. So for a vertical line, we'd be x equals 5. So horizontal needs a vertical line to be perpendicular to it. All right, go ahead and try B and C, and then check your answers. Okay, so question B, again, you have another horizontal line. So I'm not going to do another horizontal line. I'm going to use the x value to make a vertical line that is perpendicular to our y equals 9. All right, and then question C, x equals 4 is a vertical line. So I'm not focusing on that x coordinate. I'm going to focus on the y coordinate because I need a horizontal equation. Y equals -2. All right, and that kind of wraps it up. If you have time, great. You can go back to C and D, or you could work on some homework. Okay, so just a couple of reminders to wrap class up. You should have turned your city project in today. I will check off 4.1 homework tomorrow. And then I made 4.2 homework due this Wednesday, so then you can ask me any questions you might need to tomorrow. Okay, we'll do our MC tomorrow, but we'll make sure we answer any questions you might need first. All right. Hope you guys have a good day.